Ciao, ciao, ciao. Come stai, querida? Part 2 of this Road to 10 in Physics. We're going to do the exercise 24. I ask scusa for my handwriting today because I have a cut in the finger. I can't write well, però fa niente, pazienza. It says un'automobile di 800 kg parte da ferma con un'accelerazione di 0,5 metri per secondo al quadrato e la mantiene per 10 secondi. Poi prosigue a velocità constante per 15 secondi. Determina, and we have to determine three things. Yeah, first I want that always in a physics exercise you have to imagine and understand what are you doing. In this case we have a car that we can draw another car here. Yeah, this car is moving to whatever direction, it doesn't matter. Yeah, it has 800 kilograms, but the important thing is that we can describe this movement in a line of time. Yeah, it says that it moves parte de ferma. Yeah, so we can do t igual a 0, la velocidad es igual a 0 because parte de ferma, y parte de ferma con una aceleración de 0,5 metros per secondo e la mantiene per 10 secondi. So this, in all this time, acceleration equal to 0,5. E poi dice prosigue a velocità constante per 15 secondi. Yeah. So here, velocidad constante means acceleration equal to 0. And why? Because acceleration is the difference between the velocities in an interval of time. And if the velocities are the same, that it says prosigue a velocità constante per 15, V2 is igual a V1, then this is equal to 0 diviso this, and this is 0. That's why here the acceleration is 0. And for how many seconds more? For 15 seconds more. So if here we're in 10 plus 15 seconds, this finish in t equal to 25. And how much is the velocity? We don't know it, pero we're going to determine it. But we already know that it's the same that in the second 10, the second 25. Okay, that's the situation. That's what you have to understand. So mainly we can separate this movement into two smaller movements. One that starts from 0 to 10 and the other that starts from 10 to 25. Yeah, so first question, it says il valore della forza totale che agisce in ogni tratto. Yep. We have two tratto, as we say. The blue one, let's do the blue one here. The force here is going to be equal to the mass of the car multiplied the acceleration. This why? Because our friend Newton said that this is the second law. Yeah, so the force, that is what they're asking, is equal to the mass. The mass is in kilograms, so we don't have to change it. 800 kilograms. And the acceleration, how much is? 0,5 metros per segundo al cuadrado. Yeah? So the acceleration is 0,5 meters diviso segundo al cuadrado. This is the same as 800 por 0,5 por newtons, because that's the unit of Newton. 1 newton is equal to 1 kilogramo por metro partido segundo al cuadrado. Okay, and 0,5 is the same as 800 por 1 dividido 2 newton. So 8 dividido 2 es 4, so this is equal to 400 newtons. That is the same that 4 por 10 al cuadrado newtons in notación científica. So the force in the first trato is equal to 4 por 10 al cuadrado newtons. Yeah. Now the second, because they ask in both trato. in the second, the force again is going to be equal to the mass multiplied the acceleration. The mass, how much is? Still 800 kilograms. It didn't change. And acceleration, how much is? 0. And again, why is 0? Because it states here, poi prosigue a velocità constante per 15 secondi. If the velocity is constante, then the final speed minus the speed in the beginning is the same, therefore is 0. Yeah? So acceleration is going to be 0, then the force is equal to 0. I don't know what I did. Yeah, so the force in the second part is 0. Yeah. Then the answer, respuesta, force 1 is equal to 4 por 10 cuadrado n, y force 2 is equal to 0. That will be the first answer to the question. Yeah, let's do the second. It says, calcula la velocità finale raggiunta dopo la fase di accelerazione nel primo tratto, scusa, they ask la velocità finale raggiunta. Okay. First, again, we look here our situation. The car starts here with velocity 0 and starts increasing with 0.5 meters per second to the square. Yeah. But they are asking how much is the velocity when you are in the end. Yeah. We know that the velocity from here to here doesn't change because acceleration is 0. So it's enough to know how much is acceleration in this point to know how much is in all this point because it doesn't change. And how we calculate acceleration, the velocity here? Well, here is the point where it stops accelerating. And how many seconds did it spend this car accelerating? Well, all this blue thing. Then it passed accelerating 10 seconds. Okay, so accelerated 10 seconds. Yeah, and what acceleration? What it means acceleration? The change of the speed. Yeah. So we have the 0.5 meters divided seconds to the square. If we could multiply this by a second, this will be 0.5 meters divided seconds, and this is a velocity. What a coincidence. So what we're going to multiply this? The seconds. 10 seconds. Yeah. So it's going to be 0.5 per meters. It's a second to the square plus 10 seconds, and we can move it. We can put 10 multiplied by this and seconds. So this is going to be 10 por 0.5 meters divided seconds. And if we do the multiplication, this is equal to 5 meters per second. Yeah. And this is how much it changed the speed in 10 seconds. Yeah, that's what the acceleration says. How it changed the speed according to the time passed. So if you want to know how much is the final speed, you have to multiply how much it changed every second for the amount of seconds, and that is going to give you the final velocity. Yeah. Look, in the book it says B is going to be equal to B0 más la aceleración por el tiempo. That's the formula. B0 how much is? 0. Why? Because un automóvil de 100 km parte de la ferma. So velocity is equal to 0. Then you can replace it. It's going to be 0 plus acceleration 0.5 per time 10 seconds. Yeah, it's essentially the same. This is the formula. This is the way to think it. Yeah, so you can also do it with this. B0 más aceleración por tiempo. Yeah, that's the second question. Ahora preguntan la distancia total de percorsa. Ya, pues. Again, we have two movements. Here the velocity is changing, and here no. So we can separate it into two movements. And what we're going to use? The same formula. El desplazamiento, depending on the time, is equal to S0 plus P0 por T más 1/2 de la aceleración por tiempo al cuadrado. We have two moments, so we need to know how much it changed in the second 10 and how much it changed in the second part. Yeah. So let's do S de 10. S de 10 is going to be S0. We can say that is 0. We define it as 0. P0, 0, because it starts from the reposo. Plus 1 diviso 2, aceleración. How much is acceleration? 0,5. Multiplied time to the square. Time to the square. And how much is the time? 10. So it's 10 to the square. So this is essentially 1 diviso 2 multiplied 0,5 per 100. Yeah? So this is equal to, if we do this multiplication, it's 50. 550. It's 50 diviso 2, and that is equal to 25 meters. Yeah, that's the first part. So in the first part, it advanced 25 meters. Yeah, 25 meters. Now let's see in the second part. In the second part, we start here. Yeah, so we have to define ancora a new timeline. And why we have to do this? Because we can't use this formula for when the acceleration change. Yeah, and here it changed. In this case, we have that the acceleration in the beginning is 0,5 and top is 0. So we have to define again, like we're going to take only this part of the recta, so we can analyze that. So by drawing only that part of the recta, we have this, where it starts in the 10, t equal to 10, and it ends in the t equal to 25. Yeah, but what is the problem here? We have to define ancora an initial time, and that initial time is going to be here. So we're going to call another time equal to 0, and this therefore is going to be 50. Yeah, because what you do is that if 10 is equal to the 0, then you have to subtract 10 here. Yeah, the acceleration, how much is here? 0. The velocity, how much is? We just calculated. The velocity was 5 meters per second. Yeah, so here the velocity is 5 meters per second. Is the initial velocity and the final velocity. So we have espostamiento evaluated in 15, because it's the final time. It's going to be equal to S0. How much is S0? 25. Espera. Ya, scusa. Ancora. Here we define a new time, ¿cierto? Because we change the acceleration. We also have to define a new position. Yeah, in this case, the 0 was here. When I say S0 is here. Now S0 is here, because we have to change it. Yeah? And why we have to change it? Because the movement is different. That's why you have to define a new T0, a new V0, a new S0, because the movement is different. Here is blue, here is yellow. So we need different reference system. So here's going to be S0 equal to 0. In this case was S0 equal to 0. Let's put a S asterisk. So it will be S0 plus P0 por 15 más 1/2 de aceleración por tiempo al cuadrado. Yeah, how much is S0? 0. How much is V0? Well, V0 is equal to 5 meters per second. 5 meters per second. Plus 1 diviso 2 acceleration. How much is acceleration? 0. Because in this part, the yellow part, acceleration doesn't change. So we put 0. ¿Quién dice? 2 square. Yeah, so this is 0 5 times 15, that is 75, plus 0. So the spostamiento in the second part is equal to 75. In the beginning was 25, in the second part is 75, so spostamiento finale is going to be equal to spostamiento 1 plus spostamiento 2, that is equal to 25 plus 75, that is equal to 100. That is the same that this. Yeah, so the spostamiento final is that. And with that, we answered every question that they are asking. Again, the book says, per determinar la distancia totale percorsa, osserva che nel primo tratto il moto è uniformemente accelerato e nel secondo tratto è rettilineo uniforme. That's why we have to define new zeros, like T0, V0, S0, and we have to use this formula twice, because as the book says, the first one is a moto uniformemente accelerato, and el segundo è un rettilineo uniforme. So it's not the same movement, we have to use a different formula. This one I think is one of the hardest exercises that you can do, because you have to separate the movement into two. Yeah, and you have to define this T0, V0, S0 again. Like here, there is this part of the movement, and here there is this part of the movement. Yeah, you have to use the concept of acceleration, like understand what the acceleration means. Here you have to use the second law of Newton. So they ask a lot of things. Yeah, pero with time you will do it bene, so don't worry.